Here we'll be graphing tangent and cotangent functions. The graph of the tangent function can be found by looking at the unit circle, just like sine and cosine. Looking at tangent values on the unit circle, we see that the values repeat every pi. Since cotangent is the reciprocal of tangent, its values also repeat every pi. So the basic tangent and cotangent functions have periods of pi. So here are our graphs. Please note that tangent is undefined when cosine is 0, and cotangent is undefined when sine is 0. Asymptotes are going to exist at those undefined values. So those solid lines you see vertically there are actually asymptotes. Personally, these look so similar that sometimes I confuse them, that I know that they're both have a period of pi, and I know that they both have these asymptotes, but sometimes I forget where the asymptotes go, because you'll notice tangent, the asymptotes are centered on either side of the origin, but for cotangent, you have an asymptote at 0, and then the next asymptote isn't until you get to pi. So I use the unit circle to help me remember which one's which, so I don't have to memorize it. I just take a look at what's happening over here at 0 on the unit circle. This is our point 1, 0. Tangent is y over x, so 0 over 1 gives us 0. That's a defined value. But for cotangent, that's x over y, 1 over 0, and that's an undefined value. So this tells me that tangent is not going to have an asymptote at 0 because it's defined. It's 0 at 0, but cotangent will have an asymptote at 0 because it's undefined at 0. So that's just something that can help you, get started right. And then I also remember that tangent, which is the one that I use more frequently, the one I'm more comfortable with, is shaped like x to the third, which is another function I'm comfortable with. And then cotangent, well, that's going to be the flip of it. So here are our guidelines for sketching the graph of tangent and cotangent functions. Just like sine and cosine, we're going to start by identifying the period, but our formula this time is pi over b. We're going to identify and sketch the vertical asymptotes. Then we're going to divide the period formed by the vertical asymptotes into 4 equal parts, just like we did with sine and cosine. And I'm going to do the same dividing techniques to figure out how to label the tick marks properly. And then we're going to graph without any shifts. So just like sine and cosine, we're going to graph a tangent of bx or a cotangent of bx without any shifts first. So when graphing tangent, we're going to plot the points negative a at the first quarter point, 0 at the midpoint, and a at the third quarter point. And when graphing cotangent, we're going to do just the opposite of that. We're going to graph positive a at the first quarter point, 0 at the midpoint, and negative a at the third quarter point. Once we get those graphed, we're ready to do a horizontal or a vertical shift. These are exactly the same as they were for sine and cosine. The phase shift is going to be c divided by the absolute value of b, and our vertical shift is going to be d. So let's graph two periods of y equals 2 tangent of 3x. You'll notice there's not a horizontal or a vertical shift here, so this will only take one graph to graph it. We start by identifying our period. Our period is pi divided by b. So that's going to be pi divided by 3 for our period. So I'm going to do it exactly the same way I did for sine. I'm going to go out 4 marks, and that's going to be pi over 3. I'm going to divide it by 2 to get the second tick mark. So that's going to be pi over 6. And then divide it by 2 again to get the first tick mark. To get the third one, I'm going to multiply pi over 12 by 3, which when you simplify it, you're going to get pi over 4. And now we're going to do the same numbers in the left direction, the negatives. Now it's time to put in our asymptotes. Remember that tangent is defined at 0. Its asymptotes are centered about the y-axis. So that means that we're going to put an asymptote 2 to the right and 2 tick marks to the left. Now we do want to get in 2 full periods here, so I'm going to have to extend my line here. I need a 5th and a 6th line, and then we'll have another asymptote over here. Now to figure out what the numbers are, to label those at the bottom, we're just going to multiply pi over 12 by however many marks from the origin we are. So 1, 2, 3, 4. This is the 5th mark here. So we're going to multiply pi over 12 by 5. So that'll be 5 pi over 12. And then the next one's the 6th mark. 6 times pi over 12 simplifies to just be pi over 2. And now I'm ready to draw in my graph. For tangent, our first quarter mark, so in our first period, that's going to be the negative pi over 12, we're going to plot negative a. A is 2, so we're going to start at negative 2. And then in the middle, we're going to be at 0. And at the third quarter mark, we're going to be at positive a. And now we'll do that again for the second period. Our first quarter mark, we're going to be at negative a, then 0, and then positive a. And here in red, we have 2 periods of y equals 2 tangent of 3x. Next, let's graph y equals cotangent of x minus pi over 2 minus 1. We can see right away that this one actually has 2 shifts. We've got the minus pi over 2 and the minus 1. A horizontal shift and a vertical shift. That means that we're going to have to draw 3 graphs here. I'm definitely going to write myself out a plan. The first graph that we are going to graph will be y equals cotangent of x. Then we'll include the phase shift and graph y equals cotangent of x minus pi over 2. And then lastly, we will include the vertical shift and graph y equals cotangent of x minus pi over 2 minus 1. And I always like to color everything when I'm doing transformations like this. All right, let's start with that red graph. First thing we're going to need for the red graph is the period. Our period is pi over b. Our b value in this example is 1, so we get a period of pi. So we're going to go out to our 4th tick mark. That'll be pi. Divide it by 2 to get the second one. Divide that by 2 to get the first one. Multiply the first one by 3 to get the third one. And then to the left, we're just doing opposite numbers. Great. Next, we need to get our asymptotes in place. Oh, the asymptotes for cotangent, if you recall from the unit circle, cotangent is undefined at 0. So we're going to have asymptotes at 0, and then we go out 4 marks, and then we'll have another asymptote here. And then 4 marks to the left as well. Now, I'm not dashing my asymptotes here just so that they'll be easier for me to erase in a little bit when we start doing the horizontal shifts. I think I might erase them. Okay, cotangent. At the first quarter point, we are at A. A is 1 for us. At the middle point, we're at 0. And at the third quarter point, we're going to be at negative A. There's our cotangent. Let's do another period. First quarter mark, we're at A. Midpoint, we're at 0. Third quarter point, we're at negative A. So there's y equals cotan of x. Now we're ready for our horizontal shift. Our phase shift is equal to c divided by b. So that's going to be pi over 2 divided by 1, which is just pi over 2. And since it's minus, we're going to be heading to the right. Now, everything is going to shift to the right, pi over 2. And I'm happy to see that pi over 2 is one of my marks. So that tells me that everything is going to get shifted 2 marks to the right. And that does include my asymptotes. So I'm going to extend out my x-axis here so I can get 2 more marks in. And remember, we just multiply whatever the first quarter mark is by 5 and 6 to get these next 2. So this is going to be 5 pi over 4, and then 6 pi over 4, which simplifies to 3 pi over 2. And now I'm ready to shift everything to the right too, including my asymptote. So now my asymptote's going to be here, and here, and here. I'm just going to take out these yellow ones so we're not so cluttered. And now it's time to shift the actual graph portion of it. So everybody gets moved over 2 marks. And for our second period again, everybody's getting moved over 2 marks. All right, there in green, we have y equals cotangent of x minus pi over 2. The last thing we have to deal with is that minus 1 on the outside. That's a vertical shift. And we're just going to go d units in whatever direction it says. So we're going to have a vertical shift of down 1. We want to ask ourselves, are our vertical asymptotes affected by this vertical shift down 1? No, they're not. So they're going to stay right where they're at. But I do need to take the points on the green graph and shift them straight down 1 unit. And we'll do that for both periods. And here we have in the blue, y equals cotangent of x minus pi over 2 minus 1.